Alright fellas, welcome to part number 2, in which I will be telling you about how to dump the hex file that we have created in the earlier part 1 into 8051, that is this. How to dump the hex file into this. Alright, so first of all, take an Arduino cable, or we can say the USB cable, connect your PC with the Arduino. Here we go. That's the sound, and that's connected to the Arduino. Alright, so now open the Arduino IDE software. Here we go. Open the Arduino IDE software here, and you will find yourself here. Now, after opening this Arduino IDE software, go to the tools here, tools, go to the programmer and select Arduino as ISP. Okay, simple, isn't it? Select Arduino as ISP. Alright, so now go on to the files, go to the examples here, and you will find yourself here as Arduino ISP file. So open this. Alright, so you will find yourself on a code here. So shut this down up. Alright, say no here, and here we go, we are on the codes here. So you will see a code here. Alright, that is the Arduino ISP code. Alright, so we don't have to do anything here. What we do is verify this code here. Here it is, the verify button. So just verify. Here it is. It is just verifying the code here, basically. Okay, and this code has been verified in this Arduino. Alright, here we go. It's taking a bit of a time here to verify here. Alright, compiling the sketch here, and we have verified the code. Now we will do is, okay, where's the mouse? Here we go. Upload the code. Alright, successfully uploaded the code. So we have done with the next step as well. Now we will move on to the next step, that is compiling the circuit or making the circuit connections. Alright, remember fellas, you don't have to remove this IC here. Look very carefully which IC I'm trying to tell you. This IC. You don't have to remove this IC and place it on a breadboard. Instead, use this board. This board is called as 8051 development board. What is called as 8051 development board. Alright. So I guess you're clear with this board. Now we will start connecting here. Take the male female wires here. So the first connection that we have to make is pin number 11 of the Arduino. Alright, pin number 11. Okay, here 8, 9, 10, 11. Here we go. Pin number 11 of the Arduino gets connected or not? Yes, it's connected. Here we go, connected. Pin number 11 of the Arduino with the pin number, or we can say pin number 6, that is the MOSI pin. MOSI. I will come back to you what is this MOSI and all that stuff. Looks very horrible, isn't it? Yeah. So let's start connecting here. Pin number 6, that is what you can see here in this board. P10, P11. What is this? P11, P33, or P22, or P00. These are the ports. 8051 has got 4 ports: P0, P1, P2, and P3. Alright, so we're gonna use P1 port here. Alright, in this P1 port we have to use a 6th pin. Alright, so we'll start counting from here. Okay, so 1, 2, 3, 4, 5, and 6. Here we go. So we have connected pin number 11 of the Arduino with the pin number 6. Okay, sorry, my bad, I haven't connected it on pin number 6 here. Okay, so I have to just count it. Okay, once, pin number 6, it's 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7th pin from the top. Alright, so 1, 2, 3, 4, 5, 6, and here we go. So now it's connected to port 1.6 of the microcontroller. Pin number 11 to pin number 6 of the microcontroller. Take another wire, connect pin number 12 of the Arduino. Correct, pin number 12 of the Arduino board to pin number 7. Yes, that's right, just below it. Here we go, we have connected this. Alright, take another wire, connect it to Arduino's pin number 13. Here we have connected, and just below this here to the pin number 8 of the microcontroller. Okay, so now connect pin number 10 of the Arduino board with the pin number 9, that is the reset button, or we can say the reset pin of this Arduino, or we can say the microcontroller. Here we go, we have connected the reset pin here. Okay, so what I did was connect the pin number 11 of the Arduino with the pin number 6 of the microcontroller, that is port 1.5. Then connect the pin number 12 of the Arduino, yes correct, pin number 12 of the Arduino with the pin number 7 of the microcontroller, pin number 13 of the Arduino with pin number 8 of the microcontroller, pin number 8 of the microcontroller, pin number 10 of the Arduino with pin number 9, that is the reset of this microcontroller chip. Alright, so now take another wire, connect it to Arduino's VCC, that is plus 5 volt. Alright, 1 2 3 4, here we go. So we have connected the VCC here, and connect it to the VCC of this microcontroller, that is on the 40th pin here. That's correct, the 40th pin. Take another wire here, connect it to the ground of the Arduino. Alright, and connect it to the ground of the microcontroller. Yes, you can see this LED blinking here, or we can say the LED glowing. What does this mean? The connections are perfect. Alright, so we are now ready to go for the next steps. Alright, so once this LED glows, actually speaking, the development board is actually turned on. So now we can actually proceed to what we have to do the next thing. So the next thing is placing the AVR-configuration file into the C drive. Now this is a very hard term, isn't it? But that's very simple. Now I will tell you how to do this. I will give you the AVR configuration file link in the description, which I will be writing below. For short instances, I have downloaded the AVR dude configuration file here. Here we go. That's the file you have to download from the link that I will be sharing below. Right click on it, click the copy button. Alright, so where do you have to copy this? In your C drive. So I will go to this and just go here and paste. Yes, replace the file and destination. Continue. So I'm pasting it here. Here we go, we have pasted it here. Alright, so we have successfully pasted it in our C drive. Alright, so our work here till now is done. Alright, so I will be moving back here. So now find out where you have saved your hex file that I have saved in the previous video. Where did I save it? In the 8051 folder. Here we go, I found it out. Where is the hex file? Where is the hex file? I will find it in the, yes, correct. Go to the objects. You will find this hex file, which you have created in the part 1 of my video. Go here, copy this file. Alright, I have copied this file. Now the main question is, I have saved my Arduino software on the desktop. Okay, so the main problem for me lies here only. If you have saved your Arduino software in C drive, it's very simple. But if you have saved it on the desktop, you have to follow some different steps. If you have saved it in the C drive, so just go in the C drive. Alright, you will find a folder called, go in a C drive, you will find this thing there in the C drive. Wait, I will tell you what you will find in the C drive. Go in the C drive. If you have downloaded the, or we can say downloaded the what we can say Arduino software in this, or we can say indirectly that you have saved the file, Arduino file, in the C drive, you will find yourself here anywhere. So I haven't saved my Arduino project in the C drive, so I won't find it in a C drive here. I have saved it on the desktop, so I will find it on the desktop. Alright, so you will find here the Arduino folder here. Click that Arduino folder, go in the hardware, in it, go in the tools, go in the AVR bar folder, and go in the bin folder. Bouncer, isn't it? I will show you how it's done. Now in case if you have saved your Arduino software in the desktop, right click on it, go onto the file location. It will tell you where have you downloaded or where have you saved this folder. So yeah, I have to find hardware here. Where is the hardware? Here we go. Go to the hardware, go to the tools, go to the AVR, go to the bin, and just paste your hex file which you have copied a few minutes before here. Now you can see this hex file has been copied in this Arduino Arduino folder. Alright, I think you might be seeing where I'm pointing the mouse right now. Yes, to the bin button. Right click on this bin button, copy the address as a text. Alright, go to the WordPad here. I've opened it for you. Paste it here. There we go. I pasted this. Copy this thing again. Copy this whole thing now. Alright, copy this whole thing. So I've copied this whole thing. And why did I copy this? Now I'm going to tell you why did I copy this. Here we go. Go to the Windows button. Alright, you will find yourself here. Go to the search bar. Type CMD. That is the command prompt. That's correct. You will find yourself here. Don't press Ctrl V, because Ctrl V won't be accepted here. Okay, Ctrl V won't be accepted here. Is that clear? So press right button, right mouse button, paste. Here we go. Is not recognized here, so there is a problem in it. There's a problem in it. Alright, now I have done this intentionally to show you that this directly copy pasting won't help you every time. What you have to do here is type CD space and now paste your command. Now it's accepted here, isn't it? It's accepted here. So what's the next thing you have to do? The next thing you have to do is run this command. I will share in this command to you in the description given below. Alright, run this command. Before running this command, you can see here your file name. What did you save your file name as? You have to go to the 8051. What did you save your file name as? LED blinking.c, or we can say LED blink.hex. The file name that you have saved by this LED blink.hex extension, you have to write it here instead of your file name. So what I have saved here? LED blink.hex. And a very important note to be noted, write the file name as you have saved here. Alright, if the L is capital or the B is capital, it won't work or the command won't run. Alright, so go here. Alright, so I will go in the WordPad here. I will copy this whole instruction here. Just Control C, minimize this, go here, and Control V won't help, so paste. So you corrected me, congratulations. Paste. Alright, so now it says that AVR dude done, thank you. Alright, but you will see a error here. Yeah, the error. What did you see here? The AVR done thank you is not the thing which says that you are done. Look at this thing. B is not recognized as an internal or external command. You will find this problem in your code as well. So what happened here? Go back to the code again, or the command again. What is wrong with this? What we can say, the error in this command is, this command is divided into two parts, which we don't want it here. That's why we are the command prompt is showing us error here. So basically, go here, press the backspace key so that it becomes a single line command. Press space between the 89S52 and -B. So now the command is perfectly alright to be copy pasted. Just copy it, minimize. Oh sorry, I have maximized it. So minimize it and now paste it here. Here we go. Now press enter. So here we go. So we are errorless, and now AVR dude says thank you. So we are done with our coding part. Alright, so we have done our coding part. Now it's time for us to blink the LED. That's the main project, isn't it? So now we are moving on for blinking the LED. Take a breadboard. Alright, take a breadboard. So take an LED here. Alright, so now how to connect this LED? Very simple here. Just watch very carefully. The longer terminal is called the anode and the shorter terminal is called as the cathode. That's correct. So in the method 1, if you connect the shorter terminal, that is the cathode, to the ground and the anode to the port of pin number 2, so what will happen is the LED will very dimly glow, or glow very dimly. Why does this happen? This happens just because of 8051, that is this microcontroller, has to supply a huge amount of current for this LED to glow. That is 20 milliampere current has to be given to the LED to glow. But 8051 microcontroller just supplies, or has the capacity to supply or source 2 milliamperes of current. So what will happen to this LED? It will glow very dimly. If you connect the cathode, that is the negative part, to the ground, and anode to the port 2.0th pin. Alright, so that will just help you disconnect it, or we can say it will glow very dimly. In the second method, you can connect the anode of the LED. Anode is, yes, the positive part to the VCC directly, and the negative part, that is the cathode, to the pin number, or we can say the port 2.0. Why do we do this here? Actually speaking out, we do this because 8051 requires to sink a huge current that is required for the LED to glow. And as I've told you earlier, 8051 has a capacity to source the LED with 20 milliamperes of current. No, that's correct. You are correcting me. That's good. 8051 has the capacity to only source 2 milliamperes of current. But what a LED requires is 20 milliamperes. So in the method number 1, the LED glows very dimly. But in the method number 2, whatever extra amount of current that is required for this LED sinks, and therefore the LED glows very much brighter. Alright, so without wasting any time, I will show you how it's done here. Alright, so I will put it like this here. Yes, positive on the left side and negative on the right side. Alright, so now take a wire, connect the anode, that is the positive part of the LED, to the VCC here. Now very carefully, if you look, we have got some compartments for the VCC here. Here we go. Okay, the thing is not coming up in the video. Yes, VCC has got 2 pins here and ground has got 2 pins here. Alright, so I will connect it here in the VCC. Okay, what did I do here? Okay, I just took the male wires. I have to take the male female wires here. Alright, here we go. I've connected the one end here and the one end in the positive, that is the VCC here, and connect, or what we can say, the cathode terminal to the port 2.0. remember my words, port 2.0. here we go. The LED has started to blink before connecting as well. That's a magic, isn't it? So that's how you blink an LED. A simple, short, sweet and very interesting tutorial comes to an end, as well as it's the end of part number 2. Thanks for watching it, and do like, do subscribe and do comment, and if there has to be any changes to be made in my voice or maybe the teaching style, you can just tell me. Alright, thanks for watching the video, and I hope you like it, and just do it. Thank you and bye bye.